Hey guys, I just wanted to put together a little bit of a review so that you could actually watch it over again. I know sometimes it can get a little confusing when you have to rush in class, so this way you can just listen and you can rewind if you want to, and so on and so forth. So let's get So this should look pretty familiar. It's about set theory, and it says suppose each letter to the word Jones is written on 5 separate pieces of paper. The event C is choosing a consonant, which is any consonants just mean anything that's not a vowel. And event K is choosing a letter that comes before K. Alright? So when you see just the capital letter itself, it's just asking you to actually write all the elements that are a part of it. So for C, you write your weird squiggly line. And we want to see all the consonants. Now, that's not from the whole alphabet. It's from our sample space, which is Jones. Okay? So the only consonants in Jones are J. Oh, wait. I need to put that as lowercase. J. And we separate them with commas. N and S. So that's how we do the first one. For the second one, K is talking about all the letters that come after K. So that would be N, O, and S. And if you don't put it in order, that's okay. Now this one, the symbol right here means union, which means that I'm just putting the two together without repetition. So that would be J, N, O, and S. The symbol right here means intersection. In other words, what does C and K have in common? So what they do have in common is they both have an N and they both have an S. That's what I would put for that one. Now the next one, K, the complement of K, when you have that little C up top that looks kind of like an exponent, that just means the complement. So what it means is look in your sample space, which is Jones, and what are the letters in your sample space that are not in K? Alright? So the letters that are not in K but are in Jones are J, because J is not a part of it, and E. Those are the only ones that are not in K but are in our sample space, which is Jones. Okay. Now for the next 3, it's different. It's not asking you to tell us what's in these because we already did that. The P represents probability, so now we have to actually calculate what is the likelihood that if we pick one of these pieces of paper, that one of them is actually going to fall in the union of C and K. Alright, so first of all, let's count how many are in this set. So you got 1, 2, 3, and 4. So that will be our numerator, 4. And then out of our total sample space, we have 5, Jones. So it's 4 out of 5 for the first one. Now for the second one, we're going to go count again and see how many letters are in that one. So let's go ahead and count. Let's go to the intersection, which is right here. And there's 1 and 2 there. So for our fraction, our numerator is going to be 2 because there's 2 in the set, and there's 5 in our total sample space. Okay, so for the probability with set theory, your denominator is going to be the same, at least before you simplify it, because you're picking from the same sample space. Now the probability of choosing the complement to K, there's 2 ways that you can do that. Either you can find the probability of K and subtract it from 1, or you can just go ahead and count how many are in the complement. So that's 1 and 2. So that would be 2 out of 5. And lucky for us, all of our fractions have been simplified. Let's move on to the next one. The addition rule. So addition rule was the next thing that we learned about in the probability unit. And one thing that can indicate that we're using the addition rule is when you see the words or. Okay? So when you want to see the probability of one thing or another, that's generally going to use the addition rule. So that's how you can tell. All right, so the first one says, suppose the probability of having a 2-hour delay is 0.09. The probability of it snowing is 0.02. The probability of it snowing and let me underline that snowing and having a 2-hour delay is 0.01. So we want to use the addition rule, that little formula there, to actually find the probability of having a 2-hour delay or snowing. So the probability of the first thing, a 2-hour delay, is right here. So the probability of the first one is 0.09. And then we're going to add it to the probability of the second one by itself, which is 0.02. And then we're going to subtract the probability of them both happening, which is denoted right here. So we're going to subtract 0.01 from it. So when we do all that, So when we do all that, we get 0.1. So that is our final answer. There is a 10% chance, if you put it in percentages, there's a 10% chance that we either have a 2-hour delay or it's snowing. The reason why we subtract this part right here is because we don't want to count it twice. So we subtract the overlap, which gives us our final answer. Alright, let's move on to the second one. 40% of college students like country music, 30% like gospel, and 10% like both. So we have 40% for the first one, our A, 30% for the next one, our B, and 10% for the both, A and B. So the probability, I should write it all the way out, the probability of country or gospel is equal to 40% plus 30%, that's what likes gospel, and then we're going to subtract 10%, which is the overlap, both. Okay? So when you do that, you get 60%. Yay, that's our final answer. Alright, next one. Conditional probability. So, the probability of B, given that A occurred, is the probability of the both, A and B, divided by the probability of what you're given, which is A. Okay? So, Olivia and Kashana are both running for class president, and the chart shows how the students voted. So, the first probability we want to find is what is the probability that someone voted for Olivia, given that, that's what that line means, given that they are male. Okay? So if we want to translate this into our little formula there, that's our B and that's our A. Your given is what comes last. Okay? So when you're using this, a fancy way, an easier way to look at it is just put both over given. Both over given. So the probability of a male voting for Olivia is right here, and that's 40. That's where they come together, the male and Olivia. So that's going to be 40 up top. That's our both, A and B. But for our bottom, we're just going to put male because that's what's given. So that would be 40 over 67. All right. Now, for the next one, we have what is the probability that somebody voted for Kashana given that, given that they are female. So let's look at the overlap, Kashana and female, and that's 33. So that will be our numerator, because 33 females voted for Kashana. That's A and B together. But now we want to look at all of our givens. So there are 58 female, and that's what we were given. So we're choosing from the females, and that's 58. Okay. Now, a lot of you guys thought that the second question and the third question are the same, which is not true. Okay, because it's saying what is the probability that a person is female given that they voted for Kashana. So for our numerator, we still have the same overlap, which is 33, but what we're choosing from is those who voted for Kashana. So it's 33 out of 60, and that simplifies to 11 out of 20. Yay. Let's get to the next one. Where is it not working? So this next problem is also using conditional probability. The indicator that we're using conditional probability is this symbol right here. That straight line means given that. Okay, so for this one, we've been given the probabilities pretty straightforward, but you just have to remember that the probability of A given B, don't get so caught up on the letters, it just matters about the order, is equal to the probability of A and B divided by the probability of your given, which in this case is B. Okay? So you do both over your given, which is last. So the probability of A and B, and by the way, the probability of B and A and B, it means the same thing. Okay, so that probability is 0.2. We've been given that. And the probability of B is 0.6. So when we do that, when we simplify it, you just get 1/3. So that's our answer for the first one. Now for the second one, you notice the difference. What's the probability of B given A? So for that one, you still have the probability of B and A, which is the same thing as A and B, doesn't matter. I'm just putting it in order. But underneath, we're doing our given, which in this case is A. So the probability of B and A is 0.2, because it's the same as A and B. And the probability of A is 0.4, which gives us 1/2. Okay. And we're done.